In this video, we're going to take a look further at linear equations, but more specifically, identifying and graphing horizontal and vertical lines. A horizontal line like this red one, a vertical line like this blue one. A horizontal line is a line of the form y equals c, where c is a real number, and a vertical line is x equals c. This is often confusing for students because the x-axis is horizontal, but its equation is y equals 0. And the y-axis is vertical, but its equation is x equals 0. And the reason, let's look at the y-axis for example, the x-coordinate for any point along that line is 0 because I'm not moving to the right or left from the origin or from that axis. And similarly, on the x-axis, every point along that line has a y-coordinate of 0 because I didn't move away, up or down, to positive or negative y values. So y is 0 along that whole line. And so when you're asked to graph like this one, y equals 3, and you think to yourself, oh, y-axis is vertical, this is going to be a vertical line, stop yourself and take a look back at y equals 3. So go to the y-axis, find where y equals 3, and plot a point. And then take a step back and think. What is the x value? The x value is 0. Well, if I had another x value, like 4, where would I substitute that in? There is no x variable for me to substitute in. And so it does not matter what x is. Y is always 3. And we have our horizontal line here at y equals 3. I graphed that one in blue, so I'll circle it in blue. Example B, x equals -2. So we go along the x-axis to -2, plot our point, x is -2. Where would we substitute a y value other than 0? There is no y in the equation. Again, it does not matter where y is. I'm not moving anywhere to the right or left because x is defined at -2. And so the y values could be anything. X is always -2. On this maroon line. In example 2, we have a little bit of work to do beforehand. X, Y, scale. (3x equals -15). I need to isolate x, so we'll divide by the coefficient 3. X equals -5. That's the line that we will graph. It does not matter what y is, x is always -5 for this vertical line, x equals -5. Letter B, y equals 3, or y plus 3 equals 4. we need to get y by itself. We'll subtract 3 from both sides. Y equals 1. It does not matter what x is. There is no x variable for us to substitute. Y is always 1. So we go to the y-axis and find 1 and graph our line from there. Y equals 1. In a previous video, when we were talking about slope, I said we would get more specific, talking about when we had a slope equal to 0 and when we had a slope that was undefined. Any horizontal line has a slope of 0. How I remember this, I think about a treadmill. And let's put a person here. They're walking or running on this treadmill. And you know how you can raise the treadmills up so it's like you're walking up a hill? And then you could lower it back down so you're walking flat. And as you raise it up, there's a different number each time. While it's flat, walking on the horizon, you have that set at 0. And so I think a horizontal slope, because the treadmill is at a horizontal there, level 0, that's how I remember that a horizontal slope is 0. Personally, I wish that the treadmills could go down below 0 so that it would be a negative slope and you could walk down the mountain or down a hill. That would make it much easier and maybe defeat the purpose of the exercise, of course. A vertical line has an undefined slope. And I think about this as I think about a wall. And if you were to lay down on the floor with your feet at the wall, would you be able to walk up that wall and touch the ceiling without any assistance? And the answer to that is no. And because you can't walk up a wall, that's how I remember that vertical lines have undefined slopes. As we look at these next examples here, where you're asked to find the slope, you will see how in the algebra, similar to, again, that earlier video looking at slopes, how things will come together for us here. We divide 13x by 13 and negative 39 by 13 to get x by itself. X equals negative 3. What is the slope of this line? Well, I have to think earlier in this video, x equals a number is a vertical line. So, and if you don't remember that, you could quickly sketch, okay, x equals negative 3, here's x, here's y. So, negative 3, okay, it's a vertical line at x equals negative 3. And once I have that graphed, I remember, oh yeah, vertical lines have undefined slopes. Undefined. Letter B, y equals negative 3. Y is already isolated. And we saw earlier in this film that horizontal lines were in the form y equals a number. Again, if you don't remember that fact, y, x, y is negative 3, so here's our line. That is a horizontal line, and like the treadmill, the slope for that horizontal line is 0. Try letter C and D on your own. Maybe pause the video and give them a shot, and then push play when you are ready to check. x equals 19 is a line that has already isolated the variable, so we know x equals 19 is vertical, just like example A, and therefore the slope is undefined. Letter D, we isolate y by subtracting 12 from both sides of the equal sign, and we have y equals 4. This is a horizontal line, and horizontal lines have a slope of 0. Another way to check slope-intercept form of a line is y equals mx plus b. If I look at example D, y equals, there is no x, so it could be written as y equals 0x plus 4. And then we know the slope is 0. Similarly, for a vertical line, x equals 19, how would you write that in y equals mx plus b form? First of all, there's no y, and therefore I can't even begin. 0y equals there already is an equal sign with the x and the 19. It's impossible. You can't do it, which tells us the slope would be undefined. Those are a couple clues or things that might help you as you're trying to identify the slopes or whether the lines are vertical or horizontal.